Okay, so, and I'm going to leave this up here for just a second. I want to evaluate the square root of 36 minus t squared. And just take a minute and realize you couldn't do that before trigonometric substitution. You don't have an answer for how that works, right? You can't use u sub. It wouldn't help you. You can't use powers of trig. That definitely wouldn't help you. There's nothing in there for that. This isn't one of the basic rules. You're stuck. But with trigonometric substitution, you're not stuck. Okay, so I notice that this is in the form a squared minus t squared, right? So, and I'm making it sneaky right off the bat because I'm using t instead of x. All right, so if it's a squared minus t squared, I know that a is 6 because 6 squared makes 36. So I'll make a note of that. All right, so since it's 6 squared minus 30, or excuse me, 6 squared minus t squared, then I know that I will be using the substitution sine of theta is equal to x over a. So my substitution will be sine of theta is equal to t over 6. All right, now I can build a triangle from that. I'll put theta right here. Sine is opposite over hypotenuse. So I know this side over here is t, and this side over here is 6. Lovely. Now I need to find that third side. Well, I can do that because I know that, well, I know what it is. It's the square root of 36 minus t squared. But you can see it because if I call this side, I don't know, a squared plus t squared must be equal to 6 squared, which would mean a squared is equal to 36, take away t squared. So a is equal to the square root of 36, take away t squared. So that's this side right here. And I know we knew it from the page before, but that's how you can prove it. All right, so we have that, all of that loveliness. All right, now what else will we need to know? Well, we'll see what we need from the problem, right? We could find everything else that's part of that substitution if we wanted to. So we know that t would be equal to 6 sine theta, for example. We would know dt is equal to, the derivative of sine is cosine, so 6 cosine of theta d theta. I'm trying to think if there's anything else we need. Well, we'll find out. All right, so all of this is on the side, all of it. We're going to use this piece to inform what we're going to do with the integral. Now, the integral is the square root of 36 minus t squared. So I could say that's the square root of 36 minus, and instead of t squared, I'm now going to change it. So t was equal to, look at our trig substitution, t is equal to 6 sine theta. So I'm going to use that fact. So I'm going to say, all right, I'm going to change this to 6 sine of theta squared. And if I change my variable to theta, then I can't write dt. I have to write something that involves theta. So if only I had an equation that let us know what dt was. Oh, but it's right here, right? So there it is. So that's why I found those two pieces, because I knew I needed those right off the bat. So that makes this 6 cosine of theta d theta. So just so we're clear, I'm just going to find this. This is t, this is dt. Right? I'm substituting. I'm substituting in values with theta. Because I can, right? I can substitute anything and I want, as long as it all works out and makes some kind of sense and is making the problem easier. And I know it doesn't seem like it right now, but it really will. This problem will get easier. Okay, so let me make good on my promises here. So let's find this. So this is equal to the square root of 36 minus, and then if I square this, it's 36 sine squared theta times 6 cosine theta d theta. Now I notice these two terms both have a square root of 36 in it, so I'm going to factor that square root of 36 out. If you want, you can see it like this, but it's 1 minus sine squared theta, and then there's another 6 out here. Oh, I'm integrating all of this. I'm sorry. Integral, integral, integral. I haven't actually done any integration. Sorry, I lost my integral symbol. I get so excited for the substitution. All right, so 6 cosine theta d theta. Now, 6 and the square root of 36. Square root of 36 is 6. And so I'm going to have another 6 out in front. So it's 6 times 6, which is 36 integral. And then 1 minus sine squared is cosine squared, right? So from the Pythagorean identity, that would be cosine squared theta. And then cosine of theta d theta. Again, square root of 36 is 6. Maybe I should just make a little note. Right, so that's 6, and there's another 6. 6 times 6 makes 36. That's where that's coming from. Now, did you catch that? The square root of cosine squared. Interesting. So that's 36. The square root of cosine squared is cosine. And then I have another cosine. So I'm taking 36 integral cosine squared theta d theta. And now we have options, right? So we could play around with half angle identity if we wanted to. We have that choice. We also have a reduction formula from the previous section that we could use, which I think I might use. I think there might actually be a formula for this at some point in an integral formula sheet, but cosine squared isn't one of the basic ones we know right this second. But we'll get there. I'm just finding the reduction formula. Here it is. So we can use the reduction formula right here. Cosine squared is this. I mean, the other option is to use a half angle identity, but you know, use whichever one you want. Right? Use whatever is comfortable for you that you know what you're doing. So we have options. So you could use a reduction formula, which we know now from the previous section, or we could use the half angle identity. That's another option. I will use the reduction formula. So this will be 36 integral of, oh no, integral. Sorry, I'm taking the integral, so I don't need it anymore. All right, 36 times. All right, let's look at that reduction formula. It says we'll take cosine to the n minus 1. Well, n for me is 2. So it'll be cosine of x sine of x over n, which was 2, plus, and then 1 over 2 integral cosine to the 0. Well, cosine of the 0 doesn't exist, right? So let me write that. So it's cosine of theta sine of theta over 2 plus, and then the integral, 1 over 2, and then the integral of d theta. It's 1 d theta, because it'll end up canceling out for that one, right? Cosine to the 0 power, right? And the 0 power is 1. I managed to squeeze that in there. I'm excited about that. All right, so 36 over 2, because you'll notice both of these have an over 2 piece. So we'll factor that out. And that leaves me cosine of theta, sine of theta, and the integral of 1 with respect to theta is theta. So that means that I have 18, and then theta. Oh, I never figured out what theta was in terms of t. I'll have to go do that. So now I'm stuck. Now I've got to go back and figure these things out. Okay, so sine of theta I know. Sine of theta is t over 6. So this piece would be t over 6. That part I know. Theta I never figured out, so I was just avoiding it, but I'll do it. Theta is the arc sine of t over 6, right? Because if sine of theta is t over 6, then theta is the arc sine of t over 6, right? So I can actually put plus, and then theta would be the arc sine of t over 6. So that's that piece right there, that one. And then all I need to do is figure out cosine of theta. And you might think, oh no, what am I going to do? Well, you have a triangle, right? Here's theta right here. Cosine is adjacent over hypotenuse, right? So the cosine of theta, here, I'll do it in this color. Cosine of theta is adjacent over hypotenuse. So that would be the square root of 36 minus t squared over the hypotenuse of 6. So that's what I'll use. So this piece right here becomes the square root of 36 minus t squared over 6. And you're done, essentially. I mean, I can distribute the 18, and 6 times 6 is 36. So I can make that a little bit cleaner here. So this would be t divided by, 18 goes into 36 twice, square root of 36 minus t squared, plus 18 arc sine of t over 6. Oh, and I forgot one piece. Right here, after I finished my last integral, I should have put a constant of integration. So I'll just kind of throw it in right now. And there you go. It's amazing, isn't it? So to recap what you're doing, you see which form it fits into. In this case, it was form number 1. You use that substitution, you build a triangle, and then you figure out whatever parts of it you need in order to be able to make your problem work. So then you go back in here and substitute in for t, there's dt, and then you work it using your trig identities and your basic applications of integration and all of your algebra and trig know-how until you get to the very end. Don't forget your plus c once you finish, and then go back at the very end and back substitute in what t would be, or what these would be in, as terms of functions of t. And that is actually the correct integral. Crazy, but true.